Machine tools are operating machines used for processing metallic and non-metallic materials through chip removal. This process involves removing a part of the material from the workpiece to obtain a desired shape, size, or finish. Machine tools are essential in the mechanical and manufacturing industry because they allow the production of parts with great precision and repeatability. In this video, we're going to look at the main types of machine tools. We're also going to consider the types of cutting tools, the different movements and speed of machine tools. Let's get started. Machine tools are divided into two main categories: linear motion machines and rotary motion machines. In linear motion machines, the workpiece moves in a straight line. The main types are planers, shapers, grinding machines, slotting machines, and broaching machines. Planers are used for processing flat and straight surfaces on large workpieces. In these machines, the tool remains fixed while the workpiece moves back and forth. Shapers are similar to planers, but the tool moves while the workpiece stays still. They are used for small, straight cuts. Grinding machines are employed to obtain very smooth and precise surfaces, removing material with abrasive wheels using a linear motion. Slotting machines perform grooves or internal slots on cylindrical pieces, with the tool moving in a straight, vertical direction. Broaching machines are used for decorative or functional surface processing on metallic or non-metallic materials. Rotary motion machines, on the other hand, remove chips using rotating tools or rotating workpieces. They are divided into machines with non-rotating tools and machines with rotating tools. Among the first category, the most important are lathes, where the tool remains stationary while the workpiece rotates on itself. Lathes are used for external and internal cylindrical processing. In the second category, we find drills, boring machines, milling machines, and disc saws. In drills, the tool rotates to make holes of various sizes on metallic and non-metallic materials. Boring machines are similar to drills but are used to enlarge existing holes with high precision. Milling machines are equipped with a rotating tool with multiple cutting edges, allowing them to work on flat surfaces, grooves, and complex profiles. Finally, disc saws are used to cut metallic materials with a rotating abrasive or toothed disc. Classification of cutting tools. The cutting tools used in machine tools can be classified based on the number of cutting edges. Single-point tools have a single cutting edge that removes the chip in one direction. Examples of these are the tools used in lathes and planers. On the other hand, multi-point tools have multiple cutting edges that remove chips continuously and quickly. Common examples include milling cutters, drill bits, and grinding wheels. Movements of machine tools. The movements necessary for chip removal are divided into two categories: main movements and secondary movements. The main movements include the cutting motion, the feed motion, and the working motion. The cutting motion is the movement that allows the actual removal of the chip. It can be linear, as in shapers, or rotary, as in lathes and milling machines. The feed motion is the movement that moves the tool or the workpiece to allow the continuous cutting of the material. The working motion is the combination of the cutting motion and the feed motion, allowing the complete processing of the workpiece. Secondary movements include the adjustment motion and the loading and unloading motion. The adjustment motion is used to position the tool at the beginning of the process or to adjust the cutting depth. The loading and unloading motion allows the workpiece to enter the working area or exit after processing. Cutting speed. Cutting speed is the relative speed between the tool and the workpiece at the point of contact during chip removal. It is measured in meters per minute and is crucial for the quality of the machining and the lifespan of the tool. Several factors influence the cutting speed. The first factor to consider is the type of material to be processed, as hard materials require lower speeds compared to softer materials. The type of tool material also plays a significant role. Tools made of carbide or ceramic allow for higher speeds than those made of carbon steel. The chip cross-section is another important element to consider. The larger the chip section, the lower the cutting speed should be to avoid overheating. The presence of lubricant also influences the cutting speed, as lubricants reduce friction and heat, allowing higher speeds. Another aspect to take into account is the diameter of the workpiece. In lathes, a large diameter workpiece requires a lower rotational speed compared to a small diameter workpiece to maintain a constant cutting speed. Lastly, the type of machining affects the cutting speed. For example, roughing requires lower speeds compared to finishing to avoid damage. In conclusion, machine tools are at the heart of the mechanical industry. They allow the production of precise and repeatable parts in series. Understanding the operation of the different categories of machines, the classification of cutting tools, the main and secondary movements, and the cutting speed is essential for working efficiently and safely. This overview provides a general understanding of mechanical processing, which can be further explored by studying more advanced techniques and applications.